Okay, in this next video we're just going to take a look at quite straightforward information really, but it's also important as well, and it's various different types of variables for all scientific investigations. Only really two learning objectives in this area. We're going to hopefully be able to describe what's meant by an independent, a dependent and indeed a control variable. And then secondly, we'll see and hopefully be able to describe which variable is plotted on the y-axis and which is plotted on the x-axis. Now, in any scientific investigation, only two variables can change, and those two variables are the following. Firstly, the independent variable, and that's quite simply the variable that you change during that investigation. And the second one that changes is the dependent variable, and this variable changes and depends upon the independent variable. And if you just want to pause the screen, you can write down those respective notes. Now, all other things, all other variables must remain the same or be constant throughout the investigation. And this allows the investigation to establish the relationship between the independent and the dependent variable. And these other variables that are all kept the same are called control variables. And so control variables, just variables that are kept constant during the investigation. And you might just want to pause the screen and you can copy down those respective notes, please. And that quite simply ticks off the first learning objective. You can describe what's meant by the independent, dependent and control variables. Now, the next learning objective, we're going to try and see which variables plotted on which axes. So plotting the independent and dependent variables on a graph. Now, generally speaking, it's the independent variable that's plotted on the x-axis. Again, that's the one that you're changing, all right? And then the dependent variable is basically the one that's plotted on the y-axis. And this concept is shown below. So you've got your dependent variable on the y-axis and your independent variable plotted on the x-axis. And again, if you just want to pause the screen, you can copy down the notes on the graph as well. Now, the key word, come back to that previous slide, is generally, as sometimes a graph is plotted to allow you to determine something, some quantity from the gradient of that graph much more easily. And in that case, that previous analogy in relation to which variable is plotted on the x-axis and y-axis can be really inverted. And a good example of this is Hooke's law, where the graph plots the force and the extension of the respective cable. Now, in this example, in reference to Hooke's law, something that's on the current GCSE spec and A-level specification for CCEA. This is in the A2 course for the GCE. So in this example, your force, and that's the variable that you're changing. You're changing the number of masses and hence the force. Hence it's an independent variable and it's plotted on the y-axis. So in this case, we decide to plot the force, the independent variable on the y-axis, and the extension, which of course depends upon the respective force, the dependent variable, it's plotted on the x-axis. And that's like you can see in this graph down beneath. So this force extension graph, again just to stress, GCSE students, you would typically use E for extension, and then in the A-level course for A2, Unit 1, we tend to use X for displacement. So look, I've just used the GCSE one. So force extension graph, it's the independent variable plotted on the y-axis and dependent is on the x-axis. And again, we'll see in the next slide why we do that, but for now, if you want to just copy down those notes on the graph as well. Now, the reason this is the more commonly plotted graph for Hooke's law is that the relationship between the applied force, capital F, on the y-axis and the extension produced, we're using GCSE symbol E, which is on the x-axis. Well, really it's given by the equation F equals KE, and therefore the gradient of this graph gives the stiffness constant K of the material of the object directly. So you can literally plot your graph, work out the gradient of the straight, the linear proportion of the graph, and that stiffness constant K can now be found directly from the gradient as K is equal to the rise, your change in force, divided by the run, and that's your change in extension. And again, if you just want to copy down those additional notes down beneath your previous graph before we finish up this learning objective. And that finishes up the second learning objective in this lesson, and in fact that finishes up this lesson. Very straightforward, but it's important again you do understand those variables, and again which variables are plotted typically on the x and the y axes.